Hi, welcome to another video tutorial series where I will dive into neural networks and their workings. So over the past years, I had exposure to learn about neural networks from different sources. But right now, I will be following this amazing video series that has been shared by Andre, who works for Tesla. In I'll share the description, I'll share the link in my bio, but he has this amazing tutorial series which pretty much covers every mathematical details that are required to build large language models. While that is something that I'm aiming to learn over the time, at this in this process, I'm thinking to create my own notes and just keep following and create a repository for myself in this learning process. So I hope you'll join uh, in this journey, and I'll get started on giving a very high level introduction of what neural networks are from my perspective. So I believe neural networks to be a simple bridge that map input with an output. So let's consider a very simple case of classifying a picture based on the content that that picture contains. If the picture contains a dog, then we need to classify that picture to be as yes, and if the picture does not contain the dog, then we need to classify it as no. So as humans, when we see the picture, it's pretty easy for us to intuitively look for the characteristics of a dog. But when we are asked with the question on what aspects do we look in order to differentiate a dog from a cat, we will be pretty clueless. So over the generations, our mind has evolved to somehow automatically recognize a dog and a cat and the distinctions between them. So this is not an intuitive formula where we could say, hey, if the distance between the eyes is X centimeters, or if their facial features contain so and so characteristics, then we call it as a dog or it's a cat. It's something that we learned unknowingly, and we don't exactly know what rules can we apply to classify. So this is where I think neural networks can shine. So on a very simple note, neural networks are basically, you take the input, that is the image, and you multiply with some numbers, some random hypothetical numbers that we don't yet understand why they're present there, and then you'll get an output that is, you'll get the correct output basically. So this essentially is what neural networks are. The only thing that we need is we need to create a mathematical setup such that when we multiply the input with these numbers, which we call it as weights or the weight matrix, it will give us an expected output. The trick here is create a mathematical representation such that the input when multiplied with weights gives an expected output. Now, this is just for one image. We need to create this weight matrix in such a way that even with multiple images, when we multiply the weight matrix with multiple images, it gives the expected output for each of the image. So what we are essentially saying is we need this weight matrix to be scalable to classify or to work for multiple images and situations. So this is known as generalization, and neural networks, a great neural network is something that can generalize. That means we can create some kind of values inside this weight matrix when multiplied with a single image can yield the output we expect. But what we are aiming for is to predict on images that it did not see earlier. That means this weight matrix should be robust enough so that it can translate, it can be applied on images or on input data that it did not previously see. So the training of neural network should be in such a way that it should be able to generalize. So I hope this gives a good high level understanding of what neural networks are, and I'll slowly start digging deep into what different concepts that are present in the neural networks and how can we create this mathematical setup such that we get the amazing results from neural networks. Thank you. Take care and see you in the next lecture.